Hello and welcome. I'm George Crump, lead analyst with Storage Switzerland. Thank you for joining us today. Today we're going to talk about two different types of hyperconvergence that are available in the market today. One is a hardware-based only model, and the other is more of a software-based model. We're going to compare and contrast these two to try to come up with some ideas by which you guys can select the one that makes the most sense for you. Joining me to help with that conversation is Corinne. Corinne is the Vice President of Product Management for Maxta. Corinne, why don't you give the folks a little bit of background on yourself and on Maxta?
Sure. As George said, my name is Kiran. I'm in product management at Maxta. I've been in the storage industry for quite some time, close to 20 plus years. Been at other storage companies like 3PAR, HP, NetApp, and so on. So have some good background and history around the evolution of storage in general. With regards to Maxta, we'll have a little more discussion as to how we are different and how software adds a lot of value in terms of hyperconvergence during our part of the presentation. And thank you for joining.
Thank you, Corinne. And I'm George, and I'm the founder of Storage Switzerland. We've been in business now for 10 years. Prior to that, I spent about 25 years at various capacities designing different storage solutions for data centers across the United States. So let's I always like to start with sort of a level set, and let's talk about how we got to hyperconvergence, Corinne. You know, I think if you with your years of experience in mind, we probably have seen most of these transitions. In fact, some that didn't even make the slide. But you know, in the mid to late 90s, even to a degree, the early 2000s, it was all about one server, one application, and we were buying little 1U pizza boxes to put applications on. And you know, the only good thing I'll say about that environment is troubleshooting was kind of easy because you had basically one cable coming out of one computer going to one piece of storage, and so figuring out where the performance bottleneck was. You couldn't do anything to fix the bottleneck, but you could at least know where it was coming from. Then we started to move into the virtualization era, right, where now we started to look at one server and many applications, and I think we've seen a slow increase in density of virtual machines over that time. But I think that virtualization, in my mind, Corinne, was, and with your legacy, you probably saw this as well. It was really one of the first true justifications of shared storage. You know, if I think of the way we designed SANs prior to virtualized infrastructures, we created a bunch of walls and we made sure that, you know, LUN A couldn't see LUN B and things like that. But virtualization really changed that because of the kind of the construct of the clustered file system, right?
Yes, yes. I mean, it's true, and also this is very interesting to also note that another interesting question that comes to people's mind is why hyperconvergence now? Why not 3 years back, or why not 5 years back? So the idea is you brought about virtualization and the number of cores that Intel has put together on a single socket really enables applications to run on the server. I mean, previously, as George pointed out, it was always one application per server. Also because of the number of cores or the sockets that were available, the CPU horsepower that was available, it was limited. But now, especially with the latest platform, with 32 cores on a single socket, it's a lot of horsepower. And the other interesting reason is the SSDs, right? With the amount of performance that you get out of the SSD, now customers have the luxury of running multiple applications, not just applications, storage, networking, everything on standard servers.
Yeah, that's a really good point. You know, if you kind of look at the way hyperconvergence has really kind of become sort of a real center point in a lot of people's discussion, it is that. And you know, in the early days of hyperconvergence, I was somewhat critical of it because I kept thinking, okay, well, how are you going to isolate and guarantee performance? And you know, you've got these, you know, relatively highly shared architectures. Well, one answer is you have really, really fast storage, SSDs, and you know, an unprecedented amount of compute, and you basically just sort of, I call it's cutting a watermelon with a sledgehammer. You know, you just obliterate the problem, and I think that's what we saw. And so I think that we saw sort of two things start to occur as, let's say, virtualization, reached some level of maturity, right? First was this concept of convergence where, and that, Corinne, in my mind anyways, was really more of a packaging thing, right? We just, the vendor A would get with, server vendor A would get with networking vendor B and storage vendor C, and they might do some software work, but probably not. And they just kind of did some pre-integration, and you sort of got the system in a box, but it wasn't really hyperconvergence. Hyperconvergence did something different, and I think you kind of touched on it, but I want you to kind of embellish that a little bit and talk about how hyperconvergence is different than convergence.
Sure. So, I mean, if we go a little bit back in history, when people looked at the SAN storage, the idea was, as George pointed out, it's all about shared storage, ease of management compared to a single server, single application. It was much more complicated. There were more silos. You could not reuse the capacity and so on. So SAN storage became very popular in terms of leveraging shared infrastructure in their data center. But then immediately people also realized that, hey, now I need to go procure my servers separately, my storage separately, my networking separately. So people started to build converged infrastructure wherein it's packaged by a single vendor. Examples that come to mind is VCE, one of the early vendors in converged infrastructure, wherein they said, we'll put everything together. As George pointed out, very little integration work, but it's more of packaging together. But now it really helped in addressing the procurement part of it, but it did not address the ease of use point of it because it's still managing things separately or independently. Hyperconvergence essentially means that I'm integrating into the hypervisor, into the virtualization technology. This is enabling customers to just manage the object of virtualization, maybe virtual machines today, tomorrow containers, Dockers, things like that, right? So which enables customers to say, the most important thing in my data center is my applications or my object that I want to manage, and now what I need is to be able to manage that particular entity. So hyperconvergence, essentially the name as hyper stands, is integration into the hypervisor. Well integrated gives you the ease of management, which clearly differentiates between converged infrastructure and other topics like software-defined storage, which is essentially, in some sense, converged infrastructure. So hyperconvergence essentially differentiates itself with respect to converged infrastructure and software-defined storage.
Yeah, exactly. So let's dig a little deeper on the hyperconvergence topic. And there's, if I kind of laid out the pieces that are part of, I should say, of a hyperconverged system. Obviously, you have a server, or obviously in most cases multiple servers, and ranging from 2 or 3 to dozens, if not hundreds. Then you have there's obviously a network that interconnects all of those servers together. There's a hypervisor of different flavors that cluster those servers together. Then there's typically internal storage media that Corinne had mentioned, flash storage earlier, that is leveraged as part of the hyperconverged architecture. And then as Corinne had mentioned, there's also storage software, and the storage software obviously plays an important role in that it aggregates storage resources. But Corinne, there's another component here, because I always get a little concerned in that a lot of, and I'm using air quotes, which nobody on the webinar can see, but a lot of hyperconverged solutions kind of stop right there, and they're really much more of a software-defined storage solution than they are a hyperconverged solution. And one of the key elements there is VM management. So can you kind of explain what the differences are between the two?
Yeah. So as initially we started off, it's about integration into the hypervisor, and what that delivers to the customer is the object of management is a virtual machine. At the end of the day, what customers really care about in their data center is the virtual machines and the applications that are running in the virtual machines. Everything else is a supporting entity to deliver that level of service. So when I deal with a virtual machine, every aspect of it in my mind has to be configured at a virtual machine level. When it comes to hyperconvergence and integration into the hypervisor, it's all about the object of management being a virtual machine, whether it's making the number of copies for your virtual machine to deliver data availability, or whether it is providing technologies like compression and deduplication and so on, or whether it is enabling recovery of virtual machines when things fail. Which virtual machines do I recover first? Do I recover my SQL Server or my Oracle instance first, or do I recover my financial applications first? So every aspect of the thought process of an IT admin would be around virtual machine, would be around applications. So that's, in my mind at least, the most critical and the essential part of hyperconvergence. How do I make everything tied together into a VM and I manage that particular virtual machine? That's essentially, in my mind, the guts of hyperconvergence.
And so I think what I'm hearing you say there is that the management of storage and all the aspects that we kind of spend a lot of time with really become less of an issue, or really become just part of managing the VM object itself. Is that a fair way to say that?
Yeah. So, I mean, all the complexities that people today are getting used to in terms of managing storage, networking, should be done automatically. I mean, that's not what they should be spending their time on. Their time should be invested on how do I make my applications resilient? How do I make my applications have a 5 nines or a 6 nines availability? And storage or networking or any of those aspects is a supporting entity to it. And it should all be done automatically.
Okay, makes sense. So let's talk a little bit about the two types of hyperconvergence we had talked about at the beginning. And there's really, the way I see it, there's essentially two forms. There is a lot of similarities, so it's important for us to, I think, clearly differentiate the two. And so we've defined them as sort of a hardware approach, and I think you can almost think of it as a mentality, right? There's a sort of very hardware myopic view of the world, and then there's sort of a software view of the world. And in the hardware approach, what we'll typically see is it's typically delivered by a server vendor, which makes obvious sense because their job is essentially to sell more servers. And it bundles in one group servers, networking. They often either have their own hypervisor or are providing the hypervisor software with them. The storage media is already installed in those servers, and the storage software is already there. And then on the software side is, it typically provides just the hyperconvergence software, and it sort of stitches the other layers together. So they're really extracting that software component out. And the upside there is it works with multiple combinations of servers and network and different types of storage media. And so I think that we're going to go through some different scenarios and compare how these different solutions will plug in. But the important difference is that one is sort of this, I guess you could say all the logos match, and if that's really important to you, you might put a lot of value in that. And then the software approach is more of an open type of solution where you can choose whatever makes the most sense, or make it work with what you already have. So let's talk about, Corinne, some of the scenarios.
Yeah. On that slide, George, just to add to it,
sure.
The analogy that we can think of is VMware and Microsoft, right? Say VMware, when they started off, it could be that, hey, I'm just going to provide it on a single server, right? But instead, they took the approach of, hey, it should be available on every standard server in the industry, right? And similarly with Microsoft too, right? Now customers are realizing the benefit of it. Hey, I can run the hypervisor on any standard servers, pretty much anything that's available today, right? So as time goes by, the software approach has its benefit, which clearly is being demonstrated by VMware and Microsoft. Just a simple way to think about it.
Yeah, and it really makes the, to some extent, really, it makes all hardware or hardware doesn't become the differentiator, right? To your point earlier on in the presentation, really, it's all about the application, not about the server. Is that a fair way to say that?
Yep.
So what I've set up here is really two different approaches, and it's what we see really the companies from both of those spaces kind of talking about a lot. And the first is sort of the implementation aspects, and especially in what I would describe as a greenfield situation. And now it's incredibly rare to have a greenfield, totally green data center. But so most of the times these are specific projects. Virtual desktops is a really good example of it. But anytime you're kind of rolling out a very specific project. And I think there's a general theory that the hardware approach should be easier, right? Everything's kind of in the box. You buy whatever, you plug it into the wall, you hit power, and you start creating VMs or virtual desktops, what have you. And I think there's also sort of a same theory that the software solution might be more complex, because I got to go out and buy software, I got to go out and buy the hypervisor, I got to buy my media, I got to buy my network, all those different components. But I think an important aspect here, Corinne, is that in most cases the guys that are just software focused or primarily software focused have the same ability to partner with hardware vendors that the kind of hardware only guys do and deliver much the same experience, right?
Yeah. I mean, the hardware vendors, partners, distributors, software vendors have the ability to do or provide similar experience. And in some instances, I could argue maybe better in terms of support, because say the server vendors distribution, or maybe I should say break-fix distribution centers are across the globe, and they have the ability to really deliver 24/7, 4-hour or 2 hours break-fix for some of their components. So really having the software, bundling with or working with the server vendors to partner this and deliver as a solution has tremendous benefits, even when it comes to supporting break-fix models, right? Yeah,
exactly. Yeah, and I think that what we see is, I think the key thing here is flexibility, right? That there's a different group of people within the software-only model that can deliver a very similar experience to you, but gives you flexibility in, number one, it gives you flexibility in the hardware, right? Because the software vendors can partner with multiple hardware vendors. It gives you flexibility in the integrator because they can partner with multiple integrators. So I think that flexibility component, even in a greenfield situation, really has a lot of value, don't you?
Yes. I mean, customers always prefer to have some degree of choice when it comes to servers, when it comes to any hardware, so that they can decide where and which fits best for them. And software model delivers that.
Yeah, exactly. And before we move on to the next slide, I wanted to remind everybody, because we have some questions already coming in, and I realized that I didn't tell everybody about it. There's, at the bottom of your player, there is a Ask a Question button. If you click on that, type in your questions. As typically the case with one of our webinars, we've left plenty of time to get to all the questions, because I think that those really provide a lot of value for folks. So just click on the Ask a Question button and type in whatever you want, and I'm pretty sure we'll get to most of them. So the other thing, and I want to spend maybe a little bit more time here, because I just feel that this is more real world, is this sort of brownfield situation. Most data centers don't roll out a brand new project every day. They have an existing data center, they have existing compute, existing storage, existing network. And I think that this is an area where that hardware approach really struggles, because when these type of solutions first started to come out, I thought, wow, that has to be the most perfectly timed sale ever, because you have to wait till the compute, the storage, and the network all ready to replace at the same time, and I don't think that ever happens in a data center, right? So what I've seen these guys try to do in the sort of the brownfield approach is sort of get added on, if you will, to the end of the cluster, but in many cases they can't be a part of the same cluster. So as the second bullet says there, the data center ends up for a pretty significant transition time managing two independent clusters, and and that, I think, just adds to complexity, doesn't it?
Yeah, I mean, not only that, but also in a lot of scenarios, customers want to leverage some of the hardware components that they have recently purchased, right? I mean, you might have acquired a bunch of servers a year ago, and you would want to leverage as much as you can. You don't want to just discard them. And that's, in most scenarios, we have seen that quite often in our own experience in managing the data center and so on, that we have some additional servers, additional resources in the data center that we always feel, oh, it would be so nice if I can use them.
Yeah, exactly. And I think that there's one thing it seems to always be available is extra compute, right? So the ability to leverage that is really important. And so again here, I think the software approach is more practical, because I mean, Corinne, do I have this right? If I have an existing stack or existing VMware or some other hypervisor cluster, and I want to use a software-based hyperconvergence solution, I can kind of just layer that into my existing architecture, right?
That's the idea, and I mean, particularly I can talk with respect to Maxta, and that's definitely the case. And essentially, at least in our mind, from a software approach, and I'm sure you would agree to it, as that should be the model, wherein I could leverage my existing resources and be able to just add the newer technology so that I can take advantage of it.
Yeah, exactly. And so we kind of have that there in that last bullet. We can use existing resources like storage until IT is really the right guys decides to make a decision to move a data store over to the hyperconverged architecture. So it becomes a much more manageable implementation process where you can gradually move into these different environments. Now, Corinne, the other area I wanted to talk about was long-term flexibility, because in any situation, I mean, I think we spent a lot of time focusing on implementation and the difficulty or ease of implementation, but eventually everything stays for a while, and you have to be able to manage it and grow it and expand it and all that kind of stuff. And I think that, again, this is another area of really important differentiation between the two models. And so much so I have actually 2 slides on it. But if we look at kind of the hardware model, I think there's some real disadvantages here, right? So first of all, I think obviously all the hardware expansion comes from one vendor, right? And so I think one of the key challenges we see with that, and I know you've got a lot of examples as well, but what we're seeing, especially in storage right now, is sort of the rollout of NVMe, and that means we're having NVMe class servers with the ability to support NVMe drives. Well, if your hyperconverged hardware vendor is slow to move to the next generation of servers that have that direct support, you might be waiting for that performance where if you had a software solution, you wouldn't have to wait. And those sort of technology refreshes, that's a pretty common problem with these sort of more locked-in hardware solutions, right?
Yes. I mean, that's one. And the other example could also be, hey, if I'm going to add new servers or if I'm going to refresh some of the servers that I have, it's very unlikely that I'm going to go and refresh all of them at the same time. I mean, typically data centers, IT managers, they don't have the budget to go, if they have a 100-server data center, they're not going to go replace all 100 of them. They would want to replace 10 of them and then gradually expand to the newer technology and so on. So software models deliver those kind of capabilities wherein you just bring in the newer technology, expand what you have, and then gradually phase out your older technology. That to me is a huge benefit in terms of delivering or making use of the latest technology, adapting or being ahead in the curve in terms of adoption and being able to, in some sense, reduce cost, right? Because as you buy newer technology with, say, I mean, giving examples with their Intel current platform with 32 cores, I can deploy more VMs, which means I have a better consolidation. I don't need to buy 20 servers. I could just buy 10 servers now. And the cost relatively is being stable in terms of servers. They give you more capabilities, but the cost typically is almost the same as before. So gives cost benefit as well as ease of management because I'm reducing the number of servers that I'm managing. Huge benefits in that area.
Yeah, and I think the last two bullets on this page are really critical. In fact, I had to make sure I had this presentation under lock and key and highly secured because I was sure that a hardware hyperconverged vendor would hack in and try to delete these two bullets because this is huge, right? That if I buy a new server, I can't just take my software and reload it on that new server. I'm essentially buying, and the software might have been fine, and I just needed more performance. I'm essentially rebuying everything just because I wanted to upgrade hardware, and that becomes a kind of an expensive proposition, doesn't it?
Yes. Yes, absolutely. I mean, refresh costs, and the one thing is the cost, and also, I mean, the timing too, right? Previously, I mean, traditionally, I would say, people refresh their storage once in 5 years, or maybe even sometimes try to push it to 6 years. So with the newer servers technology becoming, I mean, Intel releases newer platforms once every 3 years. So now you will unnecessarily push your refresh cycles. Not only your cost is high, but you will also delay your purchases because you will end up spending a lot more money. So with this approach of software, you will reduce the cost and you will also be able to just upgrade at a much quicker rate.
Yeah, and that reminds me because I've actually seen this in the real world where a end user client that we were working with wanted to buy new servers with higher core count because they wanted to, obviously expand the number of applications and things like that they could run. So it wasn't necessarily a performance of a particular app; it was just so they could do more. And they were under pressure to reduce data center footprint, right? And so this was a way for them to do it. But because they were trying to reduce data center footprint, they were being punished and having to essentially rebuy the software. So that really just becomes a big issue, I think, in that space.
Yes, agreed.
So let's kind of talk about the software version of that, right? So in this kind of long-term view of things, I think a big one here, and I'll let you talk a little bit about this, is you can, because one of the other problems I think with the hardware model is that storage and computer is essentially tied together. But in a software model, if it's done correctly, they don't necessarily have to be tied together. Is that correct?
Yeah, and also as you have pointed out here, I mean, you might be able to get a better or you might build a better relationship with a different server vendor and not to, any names, but vendor A, you might feel that, hey, I would like to go with vendor B because of either their innovation, because of their support or whatnot. With the software model, it gives you that flexibility. With the hardware approach, it's tied by that server vendor. There is no alternative to it, right? Either you'll have to change your complete your server, your storage infrastructure completely in the data center. So it's a huge benefit.
Yeah, and so I think that this software gives you just a lot more flexibility. You can mix different nodes in. You can switch vendors. And I think it's another way of keeping vendors honest, right? If you've decided to go with, to your point, if you decided to go with vendor A and vendor A gets kind of cocky, vendor B might come in and offer you a better deal, and the ability to integrate those in without having to throw out what you already have, I think puts you in just a much better position from a business perspective, let alone from a technology perspective, right?
Yeah. And also it's a way to get best of breed across your data center. Best of breed products.
Yep, totally agree. All right, so let's kind of summarize this part here, but I think if you kind of look at it, the real only potential advantage that hardware-based convergence has is at implementation. But again, as we mentioned, software-based hyperconvergence can really overcome that by partnering with server vendors. And I just mentioned two here, Lenovo and Supermicro. There's others, so that partnering capability clearly exists. I think that also software has just a real clear advantage in brownfield implementations, as well as its advantages in long-term use of the environment. And as we have talked about, the ability to change servers and adopt new technology. So, Corinne, one of the things that I was really excited to have you guys participate in this webinar with us, because I know you guys are in that software space. So I'm going to turn the controls over to you, and why don't you kind of walk people through, kind of how you guys plug into this discussion.
Sure. Thanks, George. The next few slides, let's dive in a little more with respect to how Maxta operates, how the software model gives a better advantage to customers, and how are we different compared to the other hyperconverged vendors in the industry. The first area is around, we just wanted to highlight how Maxta, or software-based hyperconvergence in general, and Maxta in particular, delivers the benefit both in terms of ease of use and also in terms of cost. So if you look at storage arrays, it's hard to manage, and obviously the cost is much higher. Complexity comes in not only from a storage point of view, but also from managing especially if you're using fiber channel, you need to worry about the fiber channel switches, cost increases, you need to worry about LUN masking, zoning, all those aspects play in when it comes to the storage array, making it a lot more complex and very high in cost. When it comes to hardware-based HCI model, as we talked about, it definitely makes it simpler at implementation stage. You just roll in the hardware, you just plug it in, and it should work. So it makes it really simple, but the cost would not go down. I mean, it's still much more expensive compared to the software approach, maybe as much as even a storage array. It's not making the cost any cheaper, not just during implementation, but also during upgrades and refresh cycles and so on. With the software approach, it gets the benefit of both worlds in some sense, right? It brings down the complexity because similar to other hardware-based hyperconvergence approaches, you are able, as an administrator, be able to manage a virtualized object. That's a virtual machine in some sense. Makes the implementation easy, and especially as George pointed out, working with server vendors and partners, delivering that experience of plug and play makes it simple, and cost would not only be less during implementation, but more so during refresh cycles, wherein you just pay for the hardware, you don't pay for the software again. So essentially summarizes the benefits of a software-based approach of hyperconvergence compared to the storage arrays and the hardware implementation. So now let's go a little deeper into the product architecture itself. Just give you an overview and implementation of how Maxta works. Now, within this slide, if you look at these are the blue boxes in them. They are, you could assume them as servers, right? Each one of them are a server, and here the benefit that George pointed out is also that you could use different servers. You could move on. If you are going to buy a different server vendor, you could add them, and so on and so forth. So with Maxta specifically, you need a minimum of 3 servers. As we all know, in a truly distributed environment, you need a minimum of 3 servers to give you that quorum and also be able to avoid the split brain issue that we typically see. So you need 3 servers. Even here, when it comes to software approaches, especially with Maxta, you have the flexibility. The 3rd server could just be a simple pizza box. It doesn't have to have the same horsepower as the other 2. So it gives you a lot of flexibility. And we obviously, similar to other hyperconvergence approaches, Maxta would need an SSD in every server. That's where all your performance and so on would be delivered through. You would need SSDs, and you will need either all SSDs, or it would be a combination of SSDs and HDDs in every server that would be part of the cluster. So the question immediately in people's mind is, oh, if I need SSD, how much SSD do I need? On an average, if we look at it, you would typically need around 10% of the HDD capacity in SSDs if you are building a hybrid environment. If not, if it's all SSD, it's all SSD. So typically around 10% in a hybrid environment. That's where Maxta especially uses these SSDs for your caching, both read and write caching. It also, we use it to store all the metadata. In a distributed environment, it boils down to how effectively we manage data, how reads and writes happen to metadata. So we use SSDs to store all the metadata information, providing the level of performance that customers typically expect. And the next question would be, how do all these servers talk to each other? For all the communication that happens between the nodes or inter-node communication, we would use Ethernet connectivity, and Maxta specifically supports both a 1 gig network as well as a 10 gig network. And we have seen customers, most of them in their data centers are on 10 gig and they're thinking of moving higher up. But 1 gig, we have seen deployments, especially in some branch offices and so on, wherein customers still are running on a 1 gig network. So again, flexibility adds in here. Customers have the ability to use a 1 gig network or a 10 gig network, put all these things together, and now customers are able to deploy virtual machines. What Maxta software does here, as you can see, which indicated by MXSP, is all the resources around the storage resources in all the servers that are tied together would be combined together. We create a unified global data store. So what customers don't have to worry about is, how do I expose the storage? How many LUNs do I create? What do I do? None of those. Maxta software will put all the storage together, create a data store, and present this data store to the hypervisor. So once the Maxta software is installed, customers see a data store, they can start to provision VMs. So hides all the complexities of storage management from the end user, gives them one global pool. It's the same pool of storage, irrespective on what server you go and take a look at it. You will see a global pool of storage, similar to how you would think of, from a compute and memory resource point of view. What VMware did was group all the compute and memory resources together and present it to the end user to say, hey, I'm creating a VM. I need 4 vCPUs. I need 10 gigs of memory or 8 gigs of memory for this VM. You never worried about individually managing those 4 vCPUs or memory. All you had was a global pool, and you started to assign the resources. And Maxta software does exactly the same thing on the storage side. pulls everything together, gives you the ability to just select a resource, and you are done provisioning the virtual machine. Even the deployment happens within less than 30 minutes. The overall installation, and you could start, I could say, 0 to deploying a VM in less than 30 minutes. The benefit with Maxta, again, at a high level, gives you all the data services. At the end of the day, as we initially said, what customers are interested in all the data services. Is my data secure? Can I create snapshots? Do I get all the capacity efficiencies? Can I scale? So all those aspects are all delivered by Maxta. Moving on to the next slide. So the next question from in people's mind is, how does Maxta differentiate? How does they differ from other competitors in the industry? So there are three key differences. One is the choice that Maxta delivers, mainly from the software approach. You could choose the server vendor of your choice. We listed a few here, but it could include others too, like Quanta and so on. So customers get the benefit, and also they can mix and match different vendors within their clusters. So it gives a lot of flexibility. And again, from a hypervisor to two major hypervisors, VMware and KVM, gives flexibility from hypervisors to the customers. The next area is around software agility. We talked quite a bit around this, wherein gives the ability for customers to leverage their existing software licenses when they refresh their hardware. They don't have to ever pay for hardware or software once they purchase early on. They have to just refresh their hardware, they never pay for the software again. Very high ROI when it comes to refreshing their hardware infrastructure. And the third area where we differ from a technology point of view is what Maxta terms as application defined, wherein every aspect we talked about of configuring, managing is all addressed at the application level. You configure policies on a per VM basis, whether it is the amount of copies, whether it's the block size, the page size, compression, any of those aspects is all done at a virtual machine layer. Those are the three key areas where Maxta differentiates compared to other competitors in the industry. So diving a little more into the application-defined storage, what it means and why is it beneficial, just to compare, in a traditional storage model, if you look at, I'll give examples like Nimble storage, for example. They provided the ability to create a LUN with specific properties, maybe a 4K page size or an 8K page size at a LUN level still, right? So, but most of the other storage arrays don't, but it's Nimble provided that capability. Customers loved it, saying, oh, I have enormous flexibility in how I create my virtual machines on these LUNs, and I can tune it, gives better performance and so on. But again, you're still managing LUNs, and you have to make sure that all the VMs on this LUN have similar properties and so on and so forth. When hyperconvergence started off, mainly in the hardware model and some of the other software models too, customers lost that flexibility. Hyperconvergence created a pool of storage. They all had the same properties, and you just deployed a virtual machine on top of it. You lost, or as an administrator or as a customer, you lost that capability of having, or the flexibility of having the ability to configure at a LUN level when it comes to storage, but lost that flexibility. With application defined, the whole concept is provide the flexibility of configuring all these parameters at a VM level, because as we talked about, that's the object of management. So with Maxta, you could you could run multiple applications, like, for example, a SQL Server database and a web server. SQL Server database, the best practice is to configure, say, an 8K page size. For a web server, it could be a 4K page size, so that now you align your I/O based on your application. If your application demands a 64K page size like Exchange, you could configure it with a 64K page size on the storage. So even on a single cluster, you could have multiple applications with different properties coexist and provide you with the best performance. So that's a huge value in terms of customer deployments being able to consolidate applications at a much more effective way. Next, to summarize, when it comes to hardware and software implementation, just wanted to give you a few examples and thoughts in terms of how, where things fall in. Say if you look at the hardware-based implementations, they support, like say Nutanix and SimpliVity, for example, support multiple hypervisors and so on. But if you look at Cisco, for example, their implementation, it's hardware-based. They sell you an appliance, but they only support a single hypervisor. On the right side, if you look at VMware vSAN, they provide you with the software-based approach, wherein, yeah, I can run on multiple hardware, I can run on any standard servers, but you would be locked into vSphere. Customers would not have the flexibility of other hypervisors to be deployed. It doesn't mean to say that they would move away from it, but customers always want to have choice, being able to deploy VMware, and then maybe for some applications, some other hypervisors like KVM. With Maxta, essentially the way from the ground up, we started off saying, let's give that flexibility in both dimensions. Let's not tie any of our software to the hardware. It should be completely agnostic to the hardware, gives customers the ability to run on any standard servers, and then provide the ability to run multiple hypervisors. So at the end, with Maxta, you have that flexibility to choose the server platform, the hypervisor, and also be able to deliver all the standard enterprise class storage services that customers expect to within a storage platform. So with that, just an overview of Maxta. You could always visit our website, www.maxta.com. We have multiple ways in which we can do a proof of concepts. We could ship servers. We could do a hosted proof of concept, learn more about Maxta, reach out to the Maxta team. We'd be happy to do a demo, set you up with a proof of concept, and so on and so forth. With that, I would turn it over to George.
Yeah, thank you, Karan. I guess that's another thing. I was just thinking as you were going through, one of the things we didn't mention as a value or an advantage of software only, it's a heck of a lot easy to evaluate because all you got to do is download it instead of having to wait for equipment to get shipped in and get that equipment racked and all that kind of stuff too, right?
Yeah, absolutely. And I also forgot to mention one other thing. What customers at Maxta is unique in the sense is to Maxta delivers a freemium model, wherein if customers have the servers at their data center, we give them free software. They could run it. Of course, we limit it to 3 servers and 24 terabytes in capacity, but it's completely free. Provides an excellent way to get started in their data center.
Yeah, and almost on cue there. Good job, Karan. The attachments section actually has a link to the free Maxta hyperconvergence software. You'll find other links in there as well, both to articles that we've written as well as a couple of really nice success stories and also a couple of product briefs on the Maxta product. So encourage you to take a look at all of that stuff, and it's all right there for you. Let's see, so the other thing is on the webinars, this webinar will be available on demand about 5 minutes after we're done here today. So if you missed part of it, you can go back and listen to it. Also, if you have some colleagues that you think might get some interesting information from this, in the upper right-hand corner of your player, there's a little email button, and you can email the link to somebody, and same link for the live webinar will work for the on-demand webinar. So all of that information is available for you. Had a question come in asking for a copy of the presentation. We'll upload a PDF of the presentation when we're done here today. You can come back into the presentation, just download the PDF, and you should be good to go. So with that, all that housekeeping out of the way, Corinne, are you ready to go through a few questions here?
Yes, I'm
okay.
ready.
All right, so we've got a, sorry, go ahead.
Go ahead.
So we've got quite a few, so we'll just kind of go through them as we have time. So the first question is, what happens if I undersize a system?
That's an excellent question, right? Typically, customers always either oversize or undersize, and with the software approaches and with Maxta in particular, we provide a very easy scale up and scale out model. If they undersize the system, we provide the ability to replace their lower capacity drives with the higher capacity drives. Or if they have empty drive slots, they can add new drives into the system. And if they want additional CPU resources but no storage resources, they can add a compute-only node. And if they undersize it with respect to compute and storage, they can add a full storage and compute node into the cluster. So with Maxta, at least, customers don't have to worry about it. They get that enormous flexibility in terms of scale up and scale out if they undersize their system. And even if they oversize and buy more, when they install, they can exclude certain resources, install the system, run it, and if they need it, they can add them back. So a lot of flexibility there.
Okay. And the next two questions I'm going to kind of group together because they are kind of similar, but let me read them both and I'll let you comment on them. How do I manage storage performance when you have mixed drive performance on different nodes? And then the second question, is there a way to guarantee certain levels of performance to a particular VM or application? So clearly, a bunch of the listeners are worried about performance and making sure they get the best performance to the right applications. How do you guys manage through that, Corinne?
Yeah. So the first aspect in performance is all this matters if your cluster or if your applications require more performance than what your cluster can deliver. If your applications need, I'm just throwing out examples here, if 20,000 IOPS overall, and if your cluster can deliver 50,000 IOPS, none of these things really matters because you have enormous performance in your cluster. It just doesn't matter. Having said that, now we go in to say, look, how do I? First question was around how do I make sure if I have multiple drives in the cluster, how do I make sure that my performance is preserved, or what kind of performance should I expect? So the way, especially since we front-end all the drives with SSDs, now your performance typically depends on what SSD is installed on the system. So if SSDs are, if you have the same set of SSDs, the performance impact would be marginal when it comes to the hard disks if it's in a hybrid environment within the cluster. So now within the cluster itself, and if you have mixed drive types, and if it so happens that in some instances wherein there is a cache miss and we have to fetch the data, and in some instances that data happens to be on a lower performing drive, and in some instances it happens to be on a higher performing drive, the reality is you will have variance in performance. When it hits a lower capacity drive, you will have slightly lower performance. But hopefully with the caching and with the SSDs in front of these drives, that would not be the case. It will normalize the effect of lower performing drives to some extent. The second question was around how do I isolate VM performance, and is there a way to just make sure that a VM gets only certain amount of performance? With Maxta today, all our housekeeping tasks like say data resynchronization and so on and so forth are prioritized at a lower level, and we do a quality of service on those so that customers' applications are not impacted by any of the storage tasks that run in the background. But on a per VM basis, today with Maxta software, we provide the ability to isolate the capacity. You can fix the capacity. Also, you can fix the virtual machines that run on a particular node or a particular set of nodes. but we are working on the functionality wherein you can set a threshold for the latencies and the bandwidth and performance on a per VM basis. Today, it will share the resources across the cluster.
Okay, that's really good. So let's see. What if I need to scale? Actually, before we go there, I wanted to kind of back up. I think you hit a really important point at the very beginning. Is sometimes these questions are sort of driven by the fact that we don't live in the world that we live in now, where we have flash media as a pretty standard option, and then we have more compute in many cases than we know what to do with. And I would think that in most situations, it's really that first scenario that you talked about, where the cluster itself is capable of generating, I don't know, 50,000 IOPS, and the data center in total is probably capable of generating 30,000 IOPS, right? And I'm probably being very kind there. And that's probably the reality in most cases, isn't it?
Yeah, especially today with the SSDs performance, the CPU performance, and so on, the applications today cannot take advantage of it. In general, there are probably top of the pyramid a handful of applications that need maybe microsecond latencies or sub-millisecond latencies and so on. That's probably a handful. We all can count in our hands, but majority of them, say if we go with the 80-20 or the 90-10 rule, applications are not designed to take advantage of sub-millisecond latencies today. They are all happy if you can deliver single-digit millisecond, say 2 to 10 millisecond latencies.
Yeah, exactly. So let's take another question here. And I know you kind of touched on this earlier, but let's make sure we get it clear in everybody's mind. What if I need to scale storage at a faster pace than scaling compute? And I would assume that that's probably a pretty common scenario, that people start to run out of storage capacity before they run out of compute. Is there such a thing as a storage only or a storage mostly node?
Yeah, with Maxta, as we talked about, you have utmost flexibility. Yes, there is a concept of compute-only node wherein you don't add any disks to it. You just add more compute resources, CPU and memory resources. And there is also, as what the question points out here, as a storage mostly node, wherein you have very minimum compute and storage resources, because Maxta runs as a virtual machine on every node that corresponds to that cluster, irrespective whether it's a compute-only node, storage node, whatever the case may be. We always run our piece of software on it. So to run that, you need minimum CPU and memory resources. You would buy a server with minimum compute and storage, compute and memory resources, but a lot of storage resources, maybe 24-bay server with, let's say, 2 terabyte drives in them, or maybe a terabyte drive in them. So yes, you could scale independently compute and storage with the Maxta platform, and it's on demand. Hey, I need more capacity. I'm running out of it. You can pop in a few more drives, and once you do it, the resizing of the data store itself is all done automatically. And rebalancing, if you bring in a new node, if you bring in 10, say, drives into the cluster, the rebalancing of it is all done in the background automatically, and customers don't have to worry about it. And once it's all initialized, you will see the expanded capacity, and customers can start to use it.
Okay. So here's another one. What options are available for business continuance in DR? And they list, for example, are third-party apps like Veeam or Zerto supported?
Yes. All third-party applications are supported, including Veeam and including Zerto. All those are tested and supported and certified for customers to use in their data center.
Okay. Let's see, we got time for just a couple more. We'll do, I guess, what we'll call a lightning round here. So what happens if I need to do a field upgrade? Is there downtime involved?
No, with Maxta, there is no downtime involved. We do support rolling upgrade. Customers would upgrade one server at a time, and the cluster is still up. And when that node is down for maintenance, all the applications that are running on that VM will be served, the data will be served by other nodes in the cluster. So there is no downtime when you do an upgrade of either Maxta software or the hypervisor software within that cluster.
Okay. And then let's kind of end with this one, because I think that's, well, boy, there's a bunch of good questions coming in. So let's do this one. Can I use existing SAN storage in any way as I migrate?
Technology-wise, yes. You can use a SAN storage because at the end of the day, when you present a LUN, it's a disk to the hypervisor. You would create, let's say, a terabyte LUN and present it to the server, and it appears as a disk. And we can install Maxta software by utilizing that disk. And as the question rightly points out, it's mainly for migration because, I mean, as you see, its support becomes tricky when it comes to, say, EMC storage. Migration is fine, but hey, on an ongoing basis, it's just from a business point of view, I paid $500,000 for my EMC. Why would I use a different software, right? But the question rightly points out, and the answer to the question is yes. You can use SAN storage to leverage migration of data from your existing data center.
Okay. And that actually addresses a couple other questions in there as well. So we are at the top of the hour. We do have some questions that have come in that we won't be able to get to. So we'll answer those offline. So if you asked a question we didn't get to it, look for an email from one of us. Corinne, thank you very much for helping. You've added a great deal of value to the presentation today.
Thank you. Thanks, everyone. Thanks, George.
You're welcome. And real quickly, I'll put the contact information up on the screen. All of our contact information is there, so feel free to reach out to us. But for now, I'm George Crump, and for Corinne, have a great day.